In this video, we'll be discussing categorical syllogisms. If you've not yet watched the first two videos on categorical logic, you may find it helpful to watch those first. In those videos, I discussed the fact that I believe that some is best defined as not all and not none. If we adopt this definition of some, there would actually need to be some significant changes to categorical logic, and even to the categorical propositions themselves. Traditionally, there were 4 categorical propositions, but I believe you should actually have 3 categorical propositions, and that is because the 2 particular statements would actually have the exact same truth value, so we could just combine them into one claim. Now, those categorical statements, those 4 statements, were traditionally represented with the letters A, E, I, and O since the Middle Ages, which are just the first 4 vowels of the Roman alphabet. I think since we are updating the type of categorical statements that we are using, we may as well also update the letters that we use to represent them. So I'm going to use A for all SRP, B for some SRP, and C for no SRP. So since for this interpretation of categorical logic there are 3 kinds of categorical proposition and 3 categorical propositions are in a syllogism, we have 27 different moods. And there are still going to be 4 figures. The figure is determined by the location of the middle term in the premises. That means that there's going to be 108 forms in total. I have checked all of these and found the following to be valid. So we have 7 valid forms. Now that list may seem a little bit sparse, but you have to remember that this is going to be out of 108 forms rather than the 256 forms that you get with 4 categorical statements. So this interpretation is a little bit more restrictive than Aristotle's interpretation, in which you have 24 forms that are valid out of 256. But it's actually a little bit less restrictive than the Boolean interpretation, in which you have 15 valid forms out of 256. Now, when it comes to diagramming, I found that Venn diagrams did not work especially well for this type of categorical logic, for this interpretation of some. So I wanted to come up with something that was about as easy to use as Venn diagrams, but also was a more accurate representation for this interpretation. So here's going to be how we're going to diagram these statements and the reasoning behind the way that we're diagramming them. So for all SRP, assuming that S and P are not synonymous terms, in which they represent the exact same class, just called by a different name, if it's true that all SRP, then it would have to be the case that S is a subclass of P. So what we would want to do then is we would want to have the S circle be entirely contained within the P circle. So that's how we would represent all SRP. Some SRP was the most difficult to figure out, and in order to diagram some SRP, we have to consider 2 different possibilities, and we have to think about both of these when we're going to be testing for validity. For the first type, they would just be overlapping classes. So this might be something like, some dogs are fast. That just means that the classes overlap in some area. For the second type, P would be a subclass of S, as in some animals are dogs. We have to consider both of these carefully when we come up with our diagrams. No SRP would just mean that you have 2 classes that are entirely separate. So we just have 2 circles that don't have any overlap at all. Right, so the first valid form on the list is AAA1, which is also commonly known as the Barbara form. So the diagram is just meant to represent the reasoning in the premises. So all M are P, so M is a subclass of P. All S are M, which means that S is a subclass of M. So if it's the case that that M is a subclass of P and S is a subclass of M, then it would have to also be the case that all S are P. So the reason why this form is valid is that if these premises are true, there is no way that the conclusion could be false. But if you have other figures for the AAA form, it would not be valid. So for example, if you had figure 3 would have at least 3 possible diagrams, and some of those would not show that the argument is valid. So we have our premises. All M are P. Okay, so that's true in this diagram, that M is a subclass of P. All M are S. Okay, M is also a subclass of S. And then our conclusion says all S are P. But of course, this diagram shows that, in fact, only some S are P. And also, if we look down at this diagram right here, it would be the case that some S are P. Now, in this diagram over here, the conclusion would be correct. In this diagram, we do have S as being a subclass of P, so all S are P. But in 2 out of the 3 diagrams, it's actually going to be the case that some S are P follows from these premises rather than all. So this argument is not going to be valid. Of course, it wouldn't be valid either if we said some S are P, because it is also possible that it could be all S are P. So neither one of those would be a valid argument. And of course, no S are P. If the conclusion were no S or P, that wouldn't be a valid argument either. So none of the 3 statements have to follow from these premises. All right, now, one thing that you may have noticed is that I don't use an X to diagram some SRP. That is something that is commonly done when using Venn diagrams, is to use an X to represent some SRP, and it means at least one. I don't use it in that way. However, I do find the X to be useful for diagramming what are known as singular propositions. And singular propositions are just going to be statements about a particular individual thing that is named. To show this, the classic example of a valid argument is all men are mortal, Socrates is a man, therefore Socrates is mortal. Okay, so this is usually going to be translated into categorical form as all men are mortal, all things identical to Socrates are men, therefore all things identical to Socrates are mortal. Now the phrase here is a little bit strange if you're not familiar with categorical logic. It might seem kind of odd as to why you would want to use this phrase here, all things identical to Socrates. What's going on is that the belief is that you would have to create your own class, or create one class with Socrates as the lone member, and that this would enable you to be able to use some of the tools that we often use for evaluating categorical logic, for evaluating categorical logic arguments. That enables you to be able to use some of those tools to be able to turn it into a syllogism. Now, it is possible to do this. You can do it, and what this would end up being is then you could use like Venn diagrams, and you could use other tools and techniques to check for validity. But I don't really think that it's necessary. It's not that it's wrong. You can have a class with a single member, but that's not typically how we use classes, and it just results in kind of a really awkward, odd phrasing. So I think that there would be a better way of doing this, and that would be by using the X and just thinking of Socrates as being a member of a class rather than his own class. So if we're going to look at it that way, then we have our X as designating Socrates, and we say that Socrates is a member of the men class, and the men class is a subclass of mortals. Therefore, Socrates must also be a member of the mortals class. Now, if you just treated Socrates as being his own class, then it would just look like the diagram for the Barbara form, where you would just have another class right here, another circle, and it would be contained within the mortal circle. But to me, this makes it just a lot more natural and intuitive to explain it in this way. Now, I realize that I'm using the X in a much different way than how it's been used for Venn diagrams. So just to be clear, from my interpretation, it doesn't necessarily have existential import, or it doesn't necessarily mean that what you're referring to really exists. So for example, you could use the X to refer to a fictional character like Spock. So here we have an argument that is similar. All Vulcans are mortal. Spock is a Vulcan, therefore Spock is mortal. So what we would be saying then is Spock is a member of the Vulcans class, which is a subclass of the Mortals class. Therefore, Spock is a member of the Mortals class. That's essentially what you're saying. Now, I believe this argument is valid, but it doesn't really refer to anything in the actual world. So, while it is valid, it would just be hypothetical, or something that is not actual, doesn't refer to the actual world. But it still does follow. So it's valid because the conclusion follows from the premises. Now the next form we want to talk about is BAB3. I don't want to give the impression that whenever there are multiple diagrams that the argument is automatically invalid. That isn't the case. Here we have at least 3 possible diagrams for the premises, but it's going to turn out that the conclusion follows in all of them. So we have some M are P, all M are S, and then our conclusion says some S are P. And as we can see in our diagram, that is the case, that some S are P. And in these 2 diagrams as well, it would be the case that some S are P, and here as well, some S are P. So in these diagrams and any other diagrams that you would come up with, the conclusion has to be some but not all SRP. It can't be all and it can't be none. So therefore, the argument's going to be valid even though there are different diagrams that are possible. All right, so I'm not going to go through all of these, but let's just move down to a couple that are invalid. Okay, so here we have 2 premises that are particular statements, some statements. And this would be one diagram that would represent the reasoning for those statements. So some M are P. Okay, so that's how we represent that for this diagram. They're just overlapping classes. And then we have another premise, some S are M. And then our conclusion says all S are P. Well, obviously that's not the case. In this instance, they don't overlap at all. So this diagram shows no SRP. But of course, you wouldn't have to draw it like this. So don't think that no SRP is the conclusion that you would have to draw, because there are many other diagrams that are possible. And in reality, nothing actually follows from these 2 premises. So we can't say anything definitive from just these 2 premises alone. There are just too many possibilities when you have 2 particular statements. All right, so moving down. Now, what's interesting is that sometimes you'll get the same diagrams even when the premises are different. So there tends to be quite a bit of similarity in some of the diagrams that you can come up with. So in this case, we have one particular premise and one negative premise, but the diagram is going to look similar. So some M are P. Okay, once again, we're assuming for this particular diagram that they are just overlapping classes. So some M are P. And then no S are M. Well, that's true. S and M do not overlap. And then our conclusion is all S are P. But our diagram shows that actually only some S are P. So forms that have a negative premise and a particular premise, those are not going to be valid. And this is just one example of that. There could be many of them. Right, now let's move to arguments with 2 negative premises. So when there are 2 negative premises, that just means that they don't overlap at all. So we have no M or P, okay, no S or M, and then our conclusion says all S are P. But obviously our diagram here does not show that to be the case. But they could overlap. There's no particular reason why they can't overlap. So we shouldn't think that no SRP would follow either. Once again, nothing follows with certainty from just those premises. So it's just going to be an invalid form. Now let's move down to one more. So one well-known fallacy is the fallacy of the undistributed middle. So an example of this would be the following. All P are M, so our diagram shows that. All S are M, so S is a subclass of M as well. And then the conclusion says all S are P. Well, as the diagram indicates, that doesn't necessarily have to be the case. Suppose that M represents a very large class, like mammals. Well, if that's the case, then we don't really know that S must overlap P. For all we know, they could be completely independent of each other, as, say, dogs and cats would be. But it's also possible that they could overlap, or that one could be a subclass of the other. We just don't know. We can't say anything definitive when all we know is that they are both members of P, or members of M, or subclasses of M. A better way to say it would be subclasses of M. We can't say anything definitive about the relationship between S and P just because both of them are going to be subclasses of M. If you're interested in learning more about this type of categorical logic, you're welcome to download the written document, which can be found at the address listed below.